Okay, so now we're actually going to begin working our way through this open-ended task. And the very first thing that we're going to do here is we're going to input all of this information into our CAS calculators. So the GDP and life expectancy, we're going to input all of that information into our CAS calculator. And I've already done so. So here it is. I've given everything appropriate titles and I've inputted all the data. It's important that you can do this quickly, efficiently, accurately. You don't want to be wasting time in an actual SAC slowly doing this. You need to become fast at using your CAS. Okay, now having done that, let's look at the questions here. Now remember, this is a practice SAC. In your actual SAC, these questions will not be provided to you. You need to know how to structure your report in your actual SAC. But remember, if you bring this practice SAC in as a part of your bound reference, you'll know how to structure it. Your rubric will also help you know how to structure your report. So it says, look at the scatter plot of the original data and describe it and explain any implications. So let's come back to our data now and let's create a scatter plot of this. To do that, I'm going to go Control, add doc, add data and statistics, and I'm going to make this. Now, it said at the very beginning that GDP was my explanatory variable and my life expectancy was my response variable. That's what it said right up here. So we had to make sure that we were doing that correctly. We had to make sure we understood that. Now, clearly from looking at this, we can see that this looks non-linear, does it not? It looks non-linear. And that's great. That's something that we're going to comment on and draw out some implications of. Because as you can see here, what we need to do as a part of this first step is describe it and explain any implications. So there are two things we need to do. We need to describe what we've just done and explain any implications. Well, in describing it, a piece of information that I'm going to want to find is the R value. That's going to be a really useful information for describing it. Okay, so let's do that. A couple different ways of figuring out the R value. Let's just go through the most basic way, and that's coming back here, going menu, statistics, stat calculations, and then going linear regression, A plus BX, putting in the correct ones here. GDP is X, life expectancy is Y. I hit OK, and then we can come down and we can see that our R value here is 0.82488. Okay, that's great. So that's really going to help us in describing it. Let's now scroll down to this page. Okay, this is where we're going to write in our information. Now, in your actual SAC, they're never going to ask you to draw it. So right here, it's given us some axes to draw the information, but in your real SAC, they're not going to ask you to draw the scatter plot simply because it would take too long and it would be way too hard to mark as well. No one's doing that. It just takes too long and we're really getting no useful information from you. But in creating your practice SAC and having something to refer back to, it might be useful for you just to roughly sketch what this original data plot looks like. And then you can kind of see whether it's linear or not. Now, let's talk about the comment and implication that you need to provide for this based on that question before. So as you can see, here is what we're going to write. From the scatter plot, we can see there is a strong, positive, non-linear relationship between life expectancy and GDP with no obvious outliers. Now, how did we conclude that there was a strong relationship between these? Well, this was based on our R value. And we remember our R value, if we come back here and come back here, was 0.8248. Now, in your actual, so looking at that, 0.8248, we would then have to come to this and say, hey, that means it's strong. So you need to be able to use this table efficiently to say, hey, that's strong data right there. Let's not bother about writing down the R value. You can clearly see I'm 0.8248. I'm strong, so that's why I'm saying strong there. It's also positive, and we know this for a few reasons. First, just by looking at it, you can see that it's going up. But also, you can look at that, your R value, and realize that because your R value is positive, that means it's got a positive relationship as well. Now, from looking at it, you can also see that it's non-linear. Now, we'll have to prove that later on, but just from looking at the scatter plot, you can see that we've got non-linear data here. Okay, so having commented on all of those, what's the implication going to be? So from this comment and from looking at our scatter plot, what's that imply? What's our next step going to have to be? As the data appears to be non-linear, a residual analysis is required to confirm the form of the association. So now that we have drawn the scatter plot, we see that it's nonlinear. The implication that we've now drawn from that is we now need to perform a residual analysis to confirm the form of the association. Okay, so let's now come here, and let's draw our residual plot. To do that, we need to go Menu. Now, let me go through something that I think many people are going to do. They're going to go Analyze, they're going to come to Residual Plot, and it's not going to be highlighted, and they're going to have a moment of freaking out because they're like, oh no, how on earth am I going to draw a residual plot? It's not there. It doesn't give me the option of clicking it. Well, what do you have to do before you can draw your residual plot? You have to draw in your regression line. So you first have to show the regression line, always in the form a plus bx, and then having drawn this, now you can, if we come here, you can do the residual plot. So show residual plot right here. And there we go. And here it is right there. We have shown the residual plot. Remember, you first have to draw in the least square regression line before doing so. Let's just remember a few things about our residual plot before we continue on. Remember that the x-axis remains unchanged. It is the y-axis that is changed now. It is showing the distance between the regression line and the individual data points. So for instance, if I was to take, let me just get rid of that for a second. Oops, daisy. See, I deleted the, can I control Z? I deleted the least square regression line and this disappeared. If we just take one of these points here, let me just move this. Look at this point. It's 33495. If I now come straight down to here, whoopsie daisy. This is 33495, so it's the same x value, but as you can see, the y value is different. The y value is 3.57, and that's because it is above the least square regression line, so it has a positive residual. If I was to take one that is negative, so here this is 40838, and if I now come straight down to here, not that one, 40838, as you can see, the residual now is negative, and that's because this dot, it exists below the least square regression line. So it's important that you have an understanding of what the least square regression line and the residual plot are showing you. The residual plot is showing you the distance between the actual data point and whether it's above or below and by how much it is from the least square regression line. Okay, that's just a bit of a background as to what the residual plot is showing us. We now need to comment on it. Now, you could draw in the residual plot here just for your future reference. But again, just like a scatter plot would never be asked to be drawn in a real SAC, so too, we're never going to ask you to draw a full residual plot in your actual SAC, simply because it'd be a waste of time. But drawing one here for yourself, just really roughly, may be useful for you when you're looking at this in your bound notes and just looking back at it later. All right, so what can we say based on our residual plot that we've shown here? Comment. The residual plot has a, here it is, clear pattern to it of an arch. So we have a clear pattern in our residual plot. If we look over here, you've got a clear pattern going on. It isn't random. It's a clear pattern. Conclusion. The original data had a non-linear relationship. So the fact that we have a clear pattern in our residual plot is telling us that the original data is non-linear. And we could see that it was non-linear from just looking at it here, but we had to confirm it, and we confirm it through doing the residual plot. Now, what are the implications? The data must be transformed to a linear form before used to make predictions. So hopefully you can see the logic of this open-ended task that we're doing. We first draw some data using our scatter plot, and we see, oh, it doesn't look linear. It looks non-linear. We have to confirm that it's non-linear. We do that by doing the residual plot. Having now confirmed that it's non-linear, we now need to transform our data. And this might be a good time to just look through the questions again to get a sense of where we're heading. So look at the scatter plot of the original data, describe it, and describe any implications. We've done that. And remember, the implication was draw yourself a residual plot to confirm that it is non-linear. Second point, look at the residual plot and describe and explain any implications. The implications now, having confirmed that it is nonlinear, is to perform some transformations. So that's what we're going to do next. We're going to perform some transformations to our data to make it more linear, and then therefore that will allow us to perform a least square regression line to make for ourselves something that can be used for predictions. Okay, I'm going to pause here and we'll go through the next part real soon.